In the first part, we are asked to label each of these right-angled triangles with opposite, adjacent, and hypotenuse. Well, the hypotenuse is easy. It's always opposite the 90-degree angle. So this has to be the hypotenuse, this has to be the hypotenuse, this has to be the hypotenuse, and finally, this has to be the hypotenuse. The opposite and the adjacent depend on the angle that we're looking at. So in each one of these triangles, we have one of the angles marked as theta, and that's going to be our focus angle. The opposite side is always opposite the focus angle, so this has to be opposite over here. In this triangle, this has to be the opposite side over here. In this triangle, this is opposite theta, and finally in this triangle, this is opposite theta. The adjacent side is the other side, and it's also the side that encloses or helps enclose the angle that is our focus angle with the hypotenuse. So the adjacent side is here, the adjacent side is here, here, and here. Now we're being asked to state in our own words what the hypotenuse is. And I'm going to leave this up to you, but I will tell you how I look at each one of these. For the hypotenuse, I've said it many times, the hypotenuse is always the side opposite the 90-degree angle. The opposite side is the side that is opposite the angle that we're focused on. And in the triangles above, we mark that angle with theta. And finally, for the adjacent side is the one that's left, but it's also the one that helps enclose the angle or our focus angle with the hypotenuse. In the last part of the homework, we're given two triangles, triangle ABC and triangle DEF. And we're given some information. We're told in triangle ABC the hypotenuse is 5 centimeters and the opposite side or opposite to theta is 4 centimeters. So let's mark that on the triangle. We know the hypotenuse is 5 centimeters and we know the opposite side is 4. In triangle DEF, we're told that the hypotenuse is 12.5 centimeters and we're told that the adjacent side is 7.5. So again, let's put those values on our diagram. This is the hypotenuse. The adjacent side is the one that helps enclose angle alpha. Notice that we do not know whether or not angle alpha and angle theta are equal to each other. We only have the information that's on the diagram now. We're going to have to go a little bit further with these two triangles to determine whether or not they're similar. In the Introduction to Trigonometry worksheet exercise, we determined that if two triangles are similar, their sine ratios, their cosine ratios, and their tangent ratios are the same. So if we can show, let's say, sine theta equals sine alpha, then we'll know that these two triangles must be similar. So our first step is to label each one of these triangles with opposite, adjacent, and hypotenuse. We know that the longest side, or the side across from the right angle, is the hypotenuse. We know that the side opposite the angle that we're focusing on is the opposite side. And we know that the side that helps enclose the angle is the adjacent side. To calculate sine theta and sine alpha in the two triangles, we need to know the length of the opposite side and the length of the hypotenuse. In triangle ABC, we know the opposite and the hypotenuse. But in triangle DEF, we need to determine the length of the opposite side. We also have another tool that we can use. Because these are right-angled triangles and we know the length of two of the sides, we can use the Pythagorean theorem to determine the length of the other side. If we're going to use the Pythagorean theorem, we have to label each of the triangles with A, B, and C as well. In this triangle, I might as well keep the A's together. B can be over here, and C is always the hypotenuse. And again, we'll keep the A's together. B can be over here, and C is always the hypotenuse. For triangle ABC, let's calculate the length of BC, labeled A. So we're going to work on triangle ABC first, so I'll write that down so I don't get confused. I know that B is 4. I'm looking for A squared, so B is 4, so it's going to be 4 squared, and C in triangle ABC is 5. Some of you may have realized that this is one of those triangles. This is a 3, 4, 5 triangle. You can go ahead and crunch the numbers, but I guarantee you're going to figure out that A equals 3 in triangle ABC. In triangle DEF, we're looking to figure out the length of DE, which we've marked as B. So A is 7.5. We don't know what B is, so that's going to stay as B squared. And the hypotenuse, which is C, is 12.5 squared. If we go ahead and crunch the numbers, we'll determine that the value of b is 10. Let's mark these onto our diagram now that we've calculated them. So for triangle DEF, we know that the opposite side now is 10. We also know that the adjacent side in triangle ABC is 3. Now, in triangle ABC, let's determine what the sine ratio is for theta. Now, we know that sine of an angle, and in this case theta, equals the opposite over hypotenuse. And let's plug in what we know. We don't know what theta is, but we do know that opposite is 4 and the hypotenuse is 5. And if we punch this in on a calculator, we're going to get sine theta is equal to 0.8. In triangle DEF, let's do the same thing. We always start off by writing down our formula. So sine of alpha is going to equal opposite over hypotenuse. We don't know what the measure of alpha is, so we can't do anything with that, but we do know that the opposite side is equal to 10, and we know that the hypotenuse is equal to 12.5. And if we punch this in there, we're going to get 0.8 as well. So now we know that the sine of theta equals the sine of alpha, and that means that theta must equal alpha, and therefore triangle ABC is similar to triangle DEF. Now there's a number of other ways that we could figure this out. We could have looked at the corresponding sides and determined what the scale factors were for each one of them. And if all the scale factors were the same, then these two triangles would have been similar as well. But since we're doing the trigonometry unit, we might as well use trig ratios to solve it.